We'll continue our application of integration. And today we will go to finding the area between the two curves. Between two curves. So if you have now x-axis and y-axis, and you have like curve number 1 should be like that, and curve number 2 being like, say that, then the area between them is this one. So let this one be f of x, and this one be g of x. So the formula is very simple. It says the area is an integral seen from, say this is point A, so that's point A, and here is point B. So that's an integral from the points A to B, and upper curve minus the lower curve. Lower curve. So upper curve minus lower curve dx. So in this case, the area is equal to f of x, the integral from A to B of f of x minus g of x. And you could ignore the fact that if it happens that they go negative below the x-axis, then that's all taken care by the integral. So not like in the first example where we need absolute value. Similarly, they look for if you want the area bound by the curves, like a different curve there, and some so the curves between, so A and B being here, so on the y-axis, and in between them is this area. So everything changes, that the area just swap y. So this top one is f of x, f of y, so f of y, and the bottom one is g of y. So the area becomes again outer minus the lower one, which is f of y from A to B, f of y minus g of y. So obviously you need to, if the formula is given like f of x, you need to turn it into f of y. Y equals something f of x, you need to turn it into x equals something f g of y, that f whatever 2y. That's that for the area. Apart from the area, we have the formulas for finding the length of a curve. So we can remove these formulas. And do our formulas for the length of the curve. So what was here to remember is the upper curve minus the lower curve. So more, that's the area between the two curves. So apart from the area between the two curves, you have the length of a curve. So curve is like that. So what's the length of this curve here from A to B? To find the length of the curve. That there. So you use the formula like L being the length is integral from A to B, and then you have a square root of, so be careful, that's not B of the square root of B, B is the boundary. Square root of 1 plus dy by dx on the power of 2 and dx. That's your length to the curve. Also, you can find a volume of a curve. So the same curve, and you want to find the volume between A and B when the curve is rotated around the x-axis. So it's you rotate it, becomes like that, and you rotate it, bam bam bam, comes like that. So it mirrored here. So that's the shape. So this volume of the rotated curve from A to B can be around the x-axis, can be found at V for volume. V for volume will be an integral of A to B, but it is a pi in front, so pi times an integral of, and then you go y squared dx, y, let's say for y of x dx, yeah. And if it happens that you want to rotate or around y-axis rotation, the formula becomes V equals pi. So there will be an A and B, some A1 and B1, or A and B again, not to draw the second diagram. So that's the same there, just from A to B, or A1 to B1, doesn't matter, A1 to B1 of x squared dx. So this is x squared dy, sorry, because this is x of y dy. So you understand what that means? It means that, for example, if the formula is given like y equals x squared plus 2, that's y at x, and then that's rotating around x-axis, you take the same formula, but if you want to rotate it around y, then you have x squared, you turn it in the other way, equals to y minus 2, and x is equal square root of y minus 2. So therefore you use this formula here. And that's all.